Lesson 20, I will solve division problems without remainders using the area model. So we're going to be continuing what you practiced in Zern today, and we're going to be looking at a unique way to divide some division problems. I think it's going to be really challenging for you, and it'll be great for your brain. I love the way it really makes you understand how division works, so hang in there with me and do your best. And remember, if you don't understand, that just means you don't understand yet, but you have to continue trying. All right, so let's take a look at our problem set. Go ahead and write your name, and then let's take a look at the directions. Alfonso solved a division problem by drawing an area model. Look at the area model. What division problem did Alfonso solve? So remember, when you're dividing, you are taking a whole and you're dividing it into parts. And we also know that these are rectangles. And we know that whenever you are multiplying, you're taking length times width gives you the area. When you're dividing, you're taking your area and you're dividing it by the length, and that's going to give you the width. So if we took the total area of this entire rectangle, we would have to add 40 and 32, which would give us a total of 72. So we have 72, and we're dividing it by the area of 4. And altogether, that gives us 10 and 8, which would be 18. So basically, all we did was take 72 and to break it into two chunks that were easily divided by 4. So instead of using standard algorithm to divide 72 by 4, we broke it into two smaller problems that we could do really quickly in our head and add it together. I think it's a very useful strategy. So we're going to use this number bond to kind of show. So number bonds are wonderful at showing how you can break a number apart. So remember, when you make a number bond, these two, however many bonds you break it into, in this case it's only 2, they have to add together to equal 72. So when Alfonso broke 72 apart, he broke it into 40 and 32 because these two numbers together equal 72. And they're also convenient because both of these can be divided by 4 with no remainder. So if I took 40 and I divided it by 4, that would give me 10. And if I took 32 and divided it by 4, that would give me 8, and together that makes 18. So that would be a way that you could divide 72 by 4 in your head if you could break it down into two groups that are divisible by 4, which I think is kind of fun to figure out. It's kind of like a puzzle. All right, so let's take a look at 2. We're going to get a chance to make our own area model. So we're going to take 45. So there's a couple of ways in the Zern video that they did it. They just took 45 all together, and then they tried to break it down. Or sometimes they started with a number and they added to it until they got 45. Well, I think sometimes you have to be careful when you do that because sometimes you'll get a number that's not divisible by 3. But if I look at 45, there are lots of numbers in 45 that are divisible by 3. So I'm going to go ahead and put my number bond over here, and I'm going to kind of think about how I'm going to break this down. So I could do 40 and 5, but that wouldn't be a good way to break 45 apart because 40 and 5 are not divisible by 3. So I know the largest fact that I know off my head that's easily to maneuver is I know that 3 times 10 is 30. So I'm going to start by taking out this big chunk of 30. If I take 30 out of 45, well, what would be left? What plus 30 would give me 45? Well, that would be 15. So my next step is to think, okay, can I divide 30 by 3? Yes. Can I divide 15 by 3? Yes. So this is a good way to break it apart. There are other ways, but this is just the first way that come to me. So I'm going to come over here and do my area model. I'm going to make this box bigger because it represents 30, which is a bigger portion, and then I'm going to make this part 15. So since I'm dividing by 3, my width is going to be 3. So if the area is 30 and the width is 3, then what would the length be? Well, that would be 10. So if the area of this rectangle is 15 and the width is 3, what would the length be? Well, that would be 5 because 5 times 3 is 15. So over here on my number bond, if I had 30 divided by 3, I'm going to put parentheses around this, that gave me 10. And then if I had 15 divided by 3, and I'm going to put parentheses around this, and these need to be added together to give me the total, so I'm going to put an addition sign between them. 15 divided by 3 was 5, so 10 plus 5 gives me 15. So 45 divided by 3 is 15. I think it's kind of fun. All right, let's take a look at number 3. We're going to get to do another one. If you feel really confident and you enjoy this challenge just like I do, go ahead and try to do this all by yourself. The worst thing that happens is you get it wrong. You can always erase and try again. Do notice that we're going to use an area model, and we're also going to be drawing a number bond so that we can solve this problem very similar to what we did in problem 2, but it also says we have to represent the division with a written method. So we're going to have to do an extra step here. Go ahead, if you feel confident, do as much of this as you can by yourself. If you're still a little bit unsure, you can come and do it right along with me. Okay, so let's start over here with our area model. We're going to do just like we did last time, and I'm also going to come over here and draw my number bond. Now I'm going to leave a little bit of room because I also have to use a written method, which is going to be standard algorithm. So I'm going to have a number bond over here, and I'm also going to be doing standard algorithm. So we'll be dividing this by 4, okay? All right, so let's take a look here. Now my first thought is, okay, all of these numbers have to be easily divided by 4. I could go ahead and do, the biggest fact I know that multiplies by 4 is 4 times 10, which is 40. So let's do that and see if that works out. So that gives me 40. Okay, if I take 40 out of 64, what would be left? Well, that would be 24, right? Can 24 be divided by 4 with no remainder? Well, yes, it can. So that works out pretty good. So let's come over here and let's divide this into 40 and 24. If you did this on your own and you chose 2 different numbers, don't erase. Let's just see if we got the same answer. As long as you didn't choose numbers that leave a remainder, then you should be fine. All right, so let's take 40 and divide it by 4. So if my area is 40 and my width is 4, what would my length be? Well, that would be 10. If my area is 24 and my width is 4, what would my length be? That would be 6, because 6 times 4 is 24. So let's come over here. I took 40 and divided it by 4, and that gave me 10. And I'm going to add that to 24 divided by 4, which is going to give me 6, and 10 plus 6 is 16. So let's try standard algorithm and see if we get 16 too. So I take 6 tens and divide it by 4, and that gives me 1 10. 1 times 4 is 4. When I subtract, that gives me 2 tens. I add my 2 tens to my 4 ones. That gives me 24. 24 divided by 4 is 6, and 6 times 4 is 24, which gives me a remainder of 0. So I got 16, 16, and 16. All right, let's take a look at problem number 4. So again, we're going to solve using an area model. It says explain using words, pictures, or numbers the connection of the distributive property to the area model. Okay, so we're going to add an extra step in here. I'd like for you just to attempt to try to draw an area model where you can take 92 and divide it by 4. Just think to yourself, how could you possibly do that? And then let's come back and see if we come up with the same answer together. Okay, so I'm thinking to myself, what is the biggest 4 fact that I know? And the biggest 4 fact I know, again, is 4 times 10, which is 40. So I'm going to go ahead and use 40 here. So what's left over from 40 is going to be a pretty big number. So I'm thinking to myself, well, what if I did another 40? So 40 and 40 are 80. How much more do I need to get from 80 to 92? Well, from 80 to 92 is 12. So 40, 40, and 12 equal 92. And what's nice about this is divisible by 4, this is divisible by 4, and this is divisible by 4 with no remainders. So if my area is 40 and my width is 4, then what would my length be? It would be 10. And this one will be 10 too because it's the same. If this is 12 and my width is 4, then what's the length? Well, that would be 3. So my answer to 92 divided by 4 would be 10 and 10, which is 20, plus 3, which is 23. So it says I can use words, pictures, or numbers to show the connection of the distributive property to the area model. So I think I'm going to use numbers. The distributive property is where you take, whenever you're using it in division, it's how you are showing that you can break this number apart and you can divide it by 4 and put it back together. So I'm going to just show the distributive property, just like we were doing with our number bonds. So if I had 40 divided by 4 plus 40 divided by 4 plus 12 divided by 4. So this is a distributive property because I'm showing that I'm dividing all of these by the same number and then adding it together. So I had 10 plus 10 plus 3, which equals, not 13, excuse me, equals 23. So I chose to use numbers. Okay? All right, let's take a look at number 5. So we're going to solve using an area model and the standard algorithm. I'd like for you to pause the video and do as much of this as you can by yourself. If you get stuck, you can always press play. Okay, so I started with my area model and I started to think to myself, okay, what's the biggest 6 fact that I can think of really easily? And I know 6 times 10 is 60. So I chose to put 60 in the first box, which gives me a length of 10. So to get from 60 to 72, I had to add 12 more, which worked out nice because 12 is also divisible by 6. So that gave me an answer of 12. And then I had to show standard algorithm, so I came over here and I divided, and I also got an answer of 12. Okay, so today we did something pretty tricky. We used the area model to show some division and the standard algorithm. I hope that you enjoyed the challenge as much as I did. I really think that using the area model is pretty fun.